Today we're going to be talking about database DevOps. That's what we do here at Redgate. Um, and so we're going to be talking about how to do DevOps, for the database. The application is the most common, area that DevOps starts in, and the database is a little bit more challenging. And we'll get to take a look at, some of those challenges, some of the benefits that we can provide. We've got these webinars monthly, and we focus on the integration of our automation with the different source control systems and the build and release management tools that are available on the marketplace. Just as an intro, my name's Andrew Pierce. That's my email right there in my LinkedIn. I'm a sales engineer over here at Redgate. I've been here for about 3 years now, and you may have interacted with me over in support as I was over there as well. We'll just kind of go through some of our process and show a little demo alongside some of the good soft skills as well. So today our agenda, we're going to have a quick intro, and we're just going to run through these slides kind of quickly. The challenges, like I said, of database change management, and just a couple of housekeeping items too. Everyone will be on mute throughout the webinar, but please post your questions using the GoToWebinar panel over in GoToWebinar there, and we'll try to answer as many of them as possible. We'll be collecting them and answering them towards the end of the session today. For those of you that don't know Redgate, we've been around for just over 18 years. We have over 200,000 customers. We help companies improve the quality and efficiency of their SQL Server database development and deployment processes. Some of the largest, forums that we have for the community are SQL Server Central and Simple Talk. They have a pretty big presence in the community, sharing best practices, learnings, helping to solve problems with the database community. I'm sure you guys have used it once or twice, at least in the past. It saved me a few times when I was trying to understand things. But yeah, it's a great resource. And we not only talk the DevOps talk by these webinars, but we walk the DevOps walk. Over 1,000 major and minor product releases last year alone. And that really increases year by year. I've definitely seen that coming from support. And our customers range from global customers. 91% of the Fortune 100 use our tools. So very large customers, all the way down to single-person shops, consultants, etc. And so we have every end of the market, and we really try to build solutions that can be used by both small shops and the much larger shops. Our value scales. So that's all good. And so most of you have an idea about how DevOps works in the application world. You've probably seen, the application developers, using it, using DevOps processes, using DevOps tools, working in scrums maybe. But applying these same principles to the database can be a real headache. And why is that? Ultimately, a database is a really complex beast. Let's imagine a scenario for a moment. We want to make a change, however simple that may be, to our end application. A lot of dev shops out there are already using best practices around application lifecycle management and rapid delivery of their application code. So that change can be deployed very quickly. We change that line of code, and that change is moved down the pipeline. For the database, however, a similar level of change will often involve a lot of manual steps. We can maybe script the change and run the same script against different environments. Ultimately, though, deployments of databases are not as easy as swapping out old code with new. And this is our fundamental problem. We can't simply swap out a table, especially as databases hold business-critical data that needs to be safely preserved. And databases are stateful. They need to be managed as part of rolling out or updating existing software. So it's really tough to integrate the databases into the DevOps process when you have to worry about that business critical sensitive data and affecting the performance and the availability of that data to your customers. It's a huge risk potentially. Um, so because of that, there are some poor effects. If a database deployment goes wrong, and a lot of our customers have experienced those issues. So often databases are out of pace with that application development, which undermines the DevOps adoption that you're trying to push forward with. So, the application is going fast, they're implementing DevOps, and databases can sometimes be left behind. And they eventually become a bottleneck in agile delivery processes in many cases. Because of this, releases are less frequent, and so that makes each release more risky, not only for the database itself, but also any code that relies on that database change, which can often be the majority of changes. We're preventing the use of CI/CD and putting manual steps into what should be, an automated process. The more automated, the more boring. And that means that each deployment requires a lot of dev and DBA hours for troubleshooting, and which is what we're trying to avoid in the first place. It becomes stressful, demoralizing, and it's really something that you want to avoid. If something does go wrong, then we often have no way of tracing back the database change. Who made that change? When was that change made? And that can make a bug hunting a nightmare. We likely don't have any way of rolling back a change, and we're left with little options to just fix it in live. As part of our database delivery process, we need to make sure that we are executing the right changes on our target databases, going all the way to production. We also need to make sure that we have changes from all development or all developers in the right order, and that can be a cumbersome task. What we'd like to do is to bring the database into the DevOps world then. But enough of the negatives. What would we see if we could do that? What's possible if we can bring the database into the DevOps process? Well, what we'd see is that we'd be able to build repeatability into our delivery process. That means that we can continuously test the production readiness of the changes that we apply to our databases. This affords us much greater predictability, greater reliability, and a faster response time. Deploying small units of change is really the key principle here. I've talked to a lot of DBAs who are required to review thousands of lines of code when it comes to deploying a database. They normally take days, depending on how many bugs they find in the script, and maybe reordering, sending it back to the developers, that whole process. So by committing small database changes to source control on a regular basis, you can introduce automated builds and tests to make sure that all of those small units of change are tested and validated. This often happens multiple times before you are ready to deploy from dev to your next environment. And that can result in your releases being more reliable and less time consuming. Because, the more often we test, the more feedback we get. And it becomes boring at the end of the day. When you test it so many times, the release becomes boring. And everyone is a lot happier. Developers are happier as the database is no longer a bottleneck. They can work faster. DBAs are under less pressure and performing less arduous tasks, so they're happier. And most importantly, the customer is happier as they get new features quicker, bugs and known issues get cleared out sooner, and their feedback loop can be greatly reduced. Everyone loves it when a change is requested, and then they see that change promptly, quickly. Another great benefit of being able to respond to a changing landscape quickly is that suddenly our big compliance questions can be answered sooner. It's now easy for us to adopt those compliant best practices that we are maybe an afterthought beforehand. And we can go further by ensuring the steps themselves are also compliant in and of themselves. So we'll see a little bit of how that compliance actually, how can we can achieve compliance by having a process that's self-documenting. and to that compliance piece, uh, GDPR has come into play over in Europe, and several places in the U.S. are looking at GDPR as well, including a recent bill here in California. Um, and in that GDPR requirement, you know, it requires data protection by design and by default. And that aligns really well with the core fundamentals of DevOps. You know, having a reliable, repeatable, and auditable process provides a solid foundation of which we can meet this requirement. Automation can really help provide a robust and repeatable audit trail with our changes, among other things, being tracked at every single stage. We can know who did what, when, and why. In addition to this, by extending DevOps practices to the database, we no longer have to wait until the point of release to see how our software behaves. We know what to expect and reduce the risk of chaotic or even catastrophic software releases. This is key, as a catastrophic failure can result in data breach. And not just in the way you'd imagine. The definition of a data breach, according to GDPR, actually includes loss of access to data. So simply having an environment unreachable can land you in hot water. With a robust change control and testing process in place, we can ensure that we remain reliable, repeatable, and consistent, and that our process reflects that. So we actually have the 2018 State of the DevOps report available now. It's great. I recommend you take a look at it. It's a big focus for people at the moment. Every year, we run a survey of database professionals and produce this State of the Database DevOps report from the data recorded. Some of the key findings from this year's report are within 2 years, over 80% of companies will adopt DevOps. And the biggest driver for that is to increase the speed of delivery of database changes. 76% of respondents have developers in their team who work across both applications and database, so a lot of full stack developers, and that's getting more common. If you want to learn more, just go to our website, and we've got the full report there. I'm sure we can send that around afterwards if desired too. So really, how can we help? So we've talked about the challenges of database DevOps, the poor effects of not implementing DevOps for the database, and some of the benefits as well. So what would that database DevOps process kind of look like? How can we handle the challenges to reap the benefits and avoid the poor effects, right? So this is really kind of a good high-level overview of the tooling that we have and how it kind of integrates with your existing software, and that's something that we really believe in. Bring the best practices, bring the recommended software for application development, and just make it available to our database developers. So some of the core tenets of DevOps. One of the core tenets is definitely that you need to check in your code to a version control system. Your database needs to be versioned. That's really the beginning of the process. You can't really have DevOps without versioning your code. And that gives us the great visibility of who made what change, when that change was made, and why that change was made as well. To be able to track down changes and figure out what went wrong. And because of that, our tools interface with every major version control system. So Git, Subversion, Team Foundation, version control, Vault, Perforce, Mercurial. So you can bring your own version control system and put your database in there alongside your application code. And another core tenet of DevOps is to use a continuous integration engine. And our SQL change automation tool actually plugs into pretty much every CI tool imaginable. Underneath the hood of it is just PowerShell. So because of that, it's very configurable. And we actually have plugins for a lot of the major CI systems as well, and we'll get to see some of that today. So some of my favorites are TeamCity, VSTS or TFS, and then Jenkins is ever popular as well. But there's so many options for CI systems, great options. And as well as a continuous release or continuous delivery tool is also pretty useful. And that gives us the ability to deploy the changes out to multiple environments and handle that in a way where you build once, deploy many times in a repeatable, orchestrated, controlled way. And again, we plug into the existing tools such as VSTS, Octopus Deploy, Bamboo, to allow you to review those changes, those database changes, before they ever get out. And of course, on the application side or on the development side, we have some tools for your developers so that they can write code faster and test code sooner, in addition to just getting that code into your version control system. So our SQL prompt tool that I'm sure many of you are familiar with, we'll see a little bit of it today, but it helps you write code, better code faster. A lot of developers I talk to can't live without it. And then SQL test, which helps you write unit tests and also view code coverage. So we'll see a little bit of SQL test and how it integrates with SQL change automation so that we can have a CI/CD process that does our build, test, and package functions in there. And so, all of these tools that we plug into, like I said, they're commonly used for the application, and the database developers typically can't leverage them. But with our tool set, we help, or we actually leverage those great tools for the database as well. So this helps your devs work faster, which helps them do their job better. And for the DBAs who are concerned about the stability of their database, they can work safely as well because they're able to review at every step of the process, and they have great visibility into what's going out where and when that's occurring. So let's actually look at how a particular change flows through the pipeline. So first off, the developers are working in their development databases, either with their own dedicated database or in a shared development database. And they use SQL Prompt for their code suggestions to speed up development, source control perhaps, or SQL change automation to commit their code to a version control system inside of a database project there. And then SQL test to handle any sort of T-SQL-T unit tests. And T-SQL-T is an open source unit testing framework. I can discuss that more if you guys have any questions about it afterwards. And we'll see a tiny bit of it today, but we won't focus on it too much. So first of all, of course, we're just working in our development database. And then we use either SQL source control or SQL change automation to import those changes into our version control system. So let's say we're creating a table called foo and a procedure called bar. So that gets put into our version control system. We then do some validation, against those changes. So we build that package, or we build from the project that's stored in our version control system to an empty database, which we'll get to see that. We build that to an empty database to do some preliminary validation, just to check to see if there's any hanging dependencies, anything that's missing from either, the environment they're deploying to, or if, say, there's a store procedure with old references still in there. So that ensures the validity of our package. After we've done that validation, we package that up, version it in a NuGet package there, and publish it off for our release management. So the release management portion will handle the deployment out to all of our different environments, testing, QA, staging, and out to prod. And we do this in a very safe and reliable way that provides excellent visibility. We'll get to see some examples of that, and we'll actually get to see what is going to be deployed prior to it actually being deployed. So look forward to that. Also, you'll notice that at the very top here, we've got development, and development is typically just over, of course, the development environment, version control, CI, and then operations typically picks up at release management. And that's really what DevOps is about, is bringing development and operations and having them work together more closely rather than being disparate. So they can understand, the challenges of both and help to work faster, more stably. So yeah, let's actually get into the demo here, and let's take a look. So let's see. Okay. So we're going to be looking at SQL source control inside of SSMS. So our SQL source control tool is a plugin for SQL Server Management Studio. SQL Server Management Studio, you should recognize it if you do SQL Server database development. It's the most common IDE, although a lot of developers now are also using Visual Studio instead of SSMS. So you'll see in here that we're working against our widget dev 3 database. We're linked up over to a local repository here. And this is a Git repository that we're going to be working with. And you can see that we're going to be working against our master branch here. And we can handle different branches. So we can switch branches inside of our version control system. And SQL source control will recognize that, and we'll switch branches to the active branch on our local machine here. So first of all, let's start off by making a change to our database, just like I talked about inside the kind of preliminary slideshow there, and then watch as those changes are passed through the other parts of our pipeline. Today we're going to be using VSTS alongside Git in GitHub to be able to pass those changes down our pipeline. So we'll get to see how that works. So first of all, let's alter a table in here. So in here, I'm just going to go in and add a column here to our widget descriptions database, our widget descriptions table. Okay. So I'm going to add last modified here. There we go. Date, time. Cool. Okay. So I just made that change directly to my development database here. And one thing to note, when you're working with Git, with databases, and really Git it's a very common version control system that a lot of our customers use. A lot of people are looking to move to Git from other version control systems, whether it's TFVC or Subversion. But there are some, because it has some great features in it, the ability, the way that it handles branching and merging is really nice. However, there are some constraints that you have with it. Because you have kind of the distributed model of development that Git encourages, that is kind of a DevOps best practice, right? Working in a distributed model, each developer having, their own repository that they work on in their own protected environment, and then sharing those changes and merging those changes when it gets up to the remote, right? Because of that, though, it somewhat requires developers to work in a dedicated environment as well. So it it you know it's much better to actually have a dedicated development database alongside with our dedicated development repository, because I've got my local repository. It helps to have a database that is just for that repository. Um, so that's also a DevOps best practice as well. I know that that can be challenging for a lot of database developers and database administrators too, because sometimes it can cause uh, it can cause some overhead because you have to maintain some additional databases. But it is a best practice, and we do have some tools for helping with that too. SQL Clone is one of those tools. So I recommend just looking into that if that's a problem that you guys are running into. So we made our change to our table here. That looks good. Now I'm going to create a stored procedure, kind of a dummy small stored procedure here, it's more to show off SQL prompt here, as well as to just show both a table change and a procedure change, um, you know, being passed through our pipeline. So here we go. I'm going to do SSF. So this is a little snippet from SQL prompt here. I'll do it from one of our tables here. There we go. So SQL prompt here, we can just execute this. One of the features of SQL prompt is the ability to take a result set and script it as insert. So you can see that we've got the script as insert button here, as well as the open in Excel. So that allows us to open up this result set in Excel or script it as an insert clause. So that's pretty neat. Also in here, you'll notice that we've got a little green underline here. And that's because we actually do static code analysis as you're typing. So that it helps your developers get better code, tested code into your repository. And using an asterisk in the select list isn't a best practice. So that's why we got that little underline there. I'm just going to press tab here to expand the wildcard out, because that's another feature of SQL prompt. And then I'm going to just encapsulate this as a new store procedure here. And then we'll, here we go. I'll just give it a simple name, USP SSF. Okay, there we go. Cool. So here's our procedure, and we'll just execute it. So really simple procedure there, nothing fancy. And then we'll type in a quick comment, get this into our version control system, and then let's get it up to our build and release process here. Cool. So I'll type in a quick comment here. One other thing to note in here is that we can also handle data changes as well. So if you have static or reference data that you want included, we can include those as well. So for example, widget references here, if that's, say, a reference table that's used by our application and it has configuration data within it, we can add that to our repository here. And when we go to the commit tab, we'll actually see those data changes alongside the schema change as well. So this allows us to get both data and schema out and deployed to our different environments. Now, of course, we only want to include reference data that would be changed in development and deployed out. So no transactional data in here. So yeah, that's where this feature really works the best. and I'll add just a little comment. Okay, cool. So let's commit that up. We're committing to master right now. Cool. And one thing you'll note is that when we were committing, we actually saw the create script for each of these objects, and that's because we actually we store the object descriptions or the objects inside the repository as the state of the object, so the entire create script for the object, rather than as an alter or a migration script. So that's because source control here is a state solution, a stateful solution. Our SQL change automation tool that's built into Visual Studio, and you'll see that in another webinar available, I'm sure, coming up. That's more of a migrations approach, and that allows you a little more flexibility in some other ways. But the state approach is great for a lot of things. We can actually in here, after we commit that, we can actually go in and view our history here. So we pull the history from Git, and you'll see that in here. On the left-hand side, we see our revision number. And then in here, we can actually see the change type and the actual change that was made. And we can actually roll back as well if we wanted to. So we can roll back using our SQL Compare Pro tool or our SQL Data Compare Pro tool for those data changes. So this allows us, this is one way that a lot of our customers will roll back or actually roll forward, because this allows you to kind of selectively roll back. Say if we went to a very early revision here, we could open that up in SQL Compare, choose which objects we want to roll back, what data we want to roll back maybe, and then roll back our development database, commit those changes into our version control system, effectively rolling forward. So that's kind of a good DevOps best practice as well, that roll forward. We can also see the author in here as well, alongside of our comments. So it's the who made what change, when they made that change, and why that change was made visible within SSMS, as well as our version control system. So up here we've got GitHub, and actually I haven't pushed yet, so let me do that really quick here. I can push within source control here. I can also pull as well typically. So I'm going to push this up to GitHub. Right now it's just issuing a git push command. I could also use source tree or my desired Git IDE, whether that's Visual Studio, GitHub Desktop, source tree as I mentioned, or just the Git command line if as desired. And that works as well for the push. Okay, so now it's officially pushed, and let's take a look at some of our history here. So let's see. Here's our tables, and here's our commit right here. You know, part of visibility is being able to see the cohesive history of a given object, right? When was this particular table changed? How was it changed, and who made that change, right? That's, you know, that's always something that you need a good answer to, especially if it pops up or, you know, a hanging reference occurs. And we really get that answer here in our version control system. So we can see, you know, who made this change, when that change was made exactly. So in this case, we can see that we were adding a column right here. And of course, we see the author up there as well. So the version control system is the first and best way to kind of handle that information and answer those really good questions. Once it's in our version control system here, so we can see this version control system, our version control system, we can actually comment on it. We can assign, you know, we can get blame in here. You know, we can annotate it as desired, and that allows a lot of teamwork to occur. just inside of our version control system. We can issue a pull request. Maybe if your team isn't working against master like I am, you can, you know, request the DBA to pull this into master. And, you know, that master branch is basically your release branch that we're going to be building from. So let's actually take a look at building and releasing in here. So like I said, we're going to be using VSTS, and this might look a little different than what you're used to for TFS or VSTS, and that's because they've been completely changing the UI recently. I personally am a fan, but I know not everyone likes the changes. But what I do really like, and what everyone I've talked to really likes, is the active development that they have on VSTS. So our process here, you can see that we're pulling from our widgets repository up in GitHub here with term bar 1 there. And we've recently completed quite a few builds successfully. So let's queue a new build here. I don't have it building automatically, but you can set up a CI trigger to handle that. It's pretty easy inside of the tool here. And under the hood, what we're really doing is, let's see. So let's see. Let's edit our process here. Okay. Let's see. So let's look at build 162 that we just queued just now. So we'll take a look at the logs as they occur. So in the Git sources here, this is just using our plugins to Visual Studio. So it's going to be pulling down our commandlets that we use for Visual Studio. And right now it's waiting on our console output. I actually have it running on my local machine here. And here is the actual plugins here. So we're utilizing our SQL change automation plugins. Previously it was DLM automation, but now it's SQL change automation. It's really just a name change. Ultimately, it's the same power or similar PowerShell commandlets under the hood. Our source here is our GitHub project, the widgets project that we saw earlier. And in here, we're going to be first building our SQL source control project, and we're specifying our database folder, specifying our NuGet package ID, which is just our database name in this case. And then we're going to be building it to a SQL Server instance. You see that I've got my SQL Server instance specified in here with no database name. And that's because I've given the process SA permissions so that it can actually build a database, create a database, deploy it to that database just for validation purposes. Because it's just for validation purposes, it's going to drop that database immediately afterwards. And then it's validated once it's built successfully, and then we package it up inside of a NuGet package, and we drop it off inside of a path, or we actually publish it up to VSTS here. And this is our NuGet package version here. I'm just using 1.0.build ID for a nice unique build ID there. Afterwards, we've got a test step that I'm going to run. And this runs the T-SQL-T unit tests that I discussed earlier. The unit tests that I'm running are actually come out of the box. They're the SQL cop. Actually, they're more like static tests than unit tests, to be honest. But for unit tests, your developers would need to write those unit tests because they're specific to your code, essentially. It's specific to your store procedures, your functions, etc. Because they test each individual store procedure and function. So let's get back to our, oh, and afterwards, of course, we publish those test results up, and we'll get to see those. So let's get back to our console log and see how we're progressing here. Okay, so it looks like it succeeded here. So let's take a look at the results here, the output of our results. Okay, so it looks like it succeeded. Here's our logs. For our build here, we have, these are the commandlets right here. So first we're going to be doing the invoke database build. And that builds our actual process, or builds our solution. It does the validation and the packaging. And then the new database build artifact, and that actually creates our build artifact from the build itself. And once that artifact is created, it exports it up to our VSTS here. And this is actually where it's located locally on my machine. So I can actually take a look at that if I want to. And that's our NuGet package. Oh, I just need to take the NuGet package out of there. Okay. So here's our NuGet package right here. And right here. So you can see we've got the state of our database. Like I said, the state, this is the state method of deploying. So we've got the state of all of our store procedures, all of our tables, and of course, all of our T-SQL-T objects still in there, because that's what our tests are going to be running. So speaking of tests, let's take a look at our tests, the results of our tests. So it was successful, and it's utilizing the invoke database test PowerShell commandlet that we've created. And we can actually take a look at the tests here inside of VSTS. And we can see that all 6 of the tests that I've included passed. And we can take a look at what those tests are right here. So it tested ad hoc distributed queries, auto close, create statistics, update statistics, etc. So just a couple of best practices there. And so, you may include the standard SQL cop tests that test for best practices, as well as perhaps, the custom tests that your team creates for your store procedures, functions, etc. So now that we've successfully built and tested our package, we've done our CI portion of DevOps here, right? So versioned our database. That's a core tenet of CI or of DevOps. We have our build here, another core tenet of DevOps here. Now let's create our release and see what that looks like when we're actually releasing to a database. Okay, so I can create a release from here because I already have my release set up, and we'll get to see our release process in just a second here. So here's our release 99 here. Okay. And let's actually take a look at the release process as well as the output of the logs here. So we can see that we're deploying to test in UAT. I don't have prod listed in here, but we could definitely deploy out to prod as well. And so in this case, it's going to pass in parallel. So first of all, it's coming from our widget build release artifact here. And then it's going to go to test and then out to UAT. So let's see why it failed in here. So the widget build succeeded. Okay, let's see. Okay, let's actually adjust our release in here. So in here, we've got the two phases in here. First, we're going to perform the create, and then we're going to perform the deploy from resources. So that two-step process for deployment is for a very good reason here. So you saw that right here also that I just changed the version. We can choose the version of the plugin that we want to use. I'm going to use version 3 because I suspect that's why it failed in this particular case. But you can see that we're pulling our database package that we created over here. We're exporting it to a release path in here, and then we're deploying it to our target. So the create actually doesn't deploy anything. It creates our update.sql script, changes.html file, and it exports all of that out to our release path. We can then review that perhaps before deploying it. So the second step here, the perform deploy from resources, actually deploys it. And we'll get to see that as well. So I'll save this and let's queue a new release. One aspect that I like about VSTS as well is that each of these is kind of versioned. Each of these release definitions is versioned, and you can add a comment when you save it. So let's queue this off. Okay, cool. So because we have that two-step process, we can actually, let's see, here we go. We can actually separate it out and put a manual intervention step in between the two. So in here, you can see that we have the PerformCreate. Then we stop the process, and we actually have instructions for a certain set of users or a group. And that tells them basically what to do, what to review prior to actually deploying anything. So that makes a lot of DBAs happy because they can control what goes into their downstream environments. They don't have to just rely on, what the developer says is in there, or just trust the tool to deploy, whatever is necessary to sync them across. Under the hood, we're using SQL compare at every step of the way here, everywhere from source control to our CI process to our CD process here. And so that allows us to actually get that great repeatability as well. That it ensures that we're using the same engine at every step of the way. Let's adjust these as well to use the latest version here. And we'll save that off. Cool. So let's check back on our release again. Okay. Okay, it looks like the sources is having an issue actually in here. So let's take a look at that. Apologies for this, guys. Okay. 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 Let's make sure that this is still accurate here. Ah, that's why. We had a different folder name. Goodness. Okay. Darn you folder names. Okay. So let's save in queue. Okay. There we go. Oh, let's see. Let's also go back out to our UAT and make sure that this is also pulling from the correct source as well. There we go. Cool. Okay. Now that's saved. And let's release. Cool. So now our path should be correct. Okay. Now it looks like it's working. Okay. Cool. So we solved that pathing issue. And now we're going to look at what the PerformCreate does and what it outputs. So this will be what we're actually reviewing prior to deploying. So we saw our NuGet package there that has the state of our database. We're going to use that as our source, and we're going to actually create a scripts folder representation of our target, in this case, the widget test database here. And then we're going to compare between our source package, just use SQL compare our source package there, the NuGet package, to our target scripts folder there, generate our update script, create a report with all of the warnings, all of the a summary of the changes that are going to be deployed, and then the actual update script as well. So we'll get that in a nice HTML format that, let's actually take a look at that real quick. I know we're running a little bit running out of time here, but this is too good to pass up. Here we go. So this is the release right here. So you can see I actually have it in the release 101 folder. So our releases versioned here. We actually have a bunch of releases. If we wanted to take a look at a history of every release that went out, when it was created, what was actually released, we could go to any one of these folders in here to get that history, to see what was released and how. Also in here, we can see the environment where it was released. So we see test right now. When UAT deploys, we'll also see a UAT folder as well. So we'll be able to see how it deploys to each environment. In here, we've got our update script. So this is actually the SQL script that's going to run against our target. And then we have our states in here. So we've got our source. So this is the contents of our NuGet package here, including our JUnit XML file for our test results. That works really well, like I said, with VSTS, but also Jenkins can pull that in. And then also our target here. And so our target is the state of our target at the point in time that we're deploying. So let's actually let's take a look at our changes.html file. So let's go out to our reports up here because this is the most interesting thing. Let's open that up. So in here, we see our store procedure being deployed. We see our table here, and we see a few other changes as well. So these are some static data changes um, that are being modified. So we can see, when something is removed, when something's modified, and when something is being added in here. So this gives us a great idea of what's being deployed. And then the warnings here would let us know if there were any issues with the deployment. So if this was going to cause re-indexing to occur, if this was going to drop data, et cetera, we'd see that inside of our warnings here. And then we've got our full SQL script in here as well. This is the actual update script that's going to be run against our target in here. So we can see all of the procedure in here, and we see all of the data as well. And we actually do, for the data, we do a comparison. So we compare source to target. And in this case, we had to we're issuing updates because the data was different between the source, which is our NuGet package, and our target, which is our widget test there. So we're issuing update scripts, but if you remove data, it would issue deletes. If you added data, it would issue inserts. And of course, we see our alter table add column in here, even though we store it inside our repository as a create script, a modification to our create script. When it's actually deployed, our tool, because we're using SQL compare under the hood, it issues an alter table add column in there. So also, I just want to let you know that if for whatever reason we're not able to get to your questions today, we'll make sure to answer them tomorrow as well. So yeah, I kind of want to just open it up to questions now. I know we're coming up to right to the end of our time here. But yeah, let's take a look at some of the questions that we have. So the first question is, how do you recommend handling CI testing for parallel development using branches? What are the changes? When are the changes tested / integrated? Yeah, that's a great question. So in parallel development processes, developers working against the same database, but working on different change sets. So for one thing, our T-SQL-T unit tests, SQL test is a tool that actually plugs into SSMS here. So we can open that up. So we can actually test as a developer, we can write our tests and we can run our tests in our development environment here. It doesn't actually need to go out to our CI process in order to begin testing. So we can do some of that here locally. It's not we won't be doing the build necessarily, the validation. That'll be saved for when we actually merge our development back together into master. Let's say we're working on the parallel branches, and then we issue a pull request. DBAs or who maybe the lead developer reviews those changes, approves them for release. And once those changes are approved, they're merged into or pulled into our master branch, and then we spin up our CI build test process from there and deploy. So the answer is, upon merge into the release branch, that's typically how our customers will handle it. However, there are ways to test it before it even gets there. So SQL change automation, so the question is, which servers need to have SQL change automation installed? So SQL change automation is our cmdlets that use SQL compare under the hood, and those need to be installed on the build agents or the build servers you know, which are running the build and release process. So yeah, that's it looks like that's all we'll have time for today. I'll make sure to answer the rest of the questions that were asked via email. I really thank you guys for joining us. I hope this was helpful. And please, if there are any questions, so we didn't get to all questions, but if there were even more questions that you guys didn't ask or you think of later, just let us know, and we're happy to answer those. I hope you guys have a great day, great weekend, and thanks for joining us. Take care.